Hello and good day to everyone. I'm Chai Ming Choy. Today, I will be presenting my Psda project tool for the subject Probability and Statistical Analysis to you. The title of my project is Student Grade Prediction. For introduction, the purpose of this project is to investigate whether there is a relationship between the student's address type, their internet access at home, their first period grade G1, second period grade G2, and their final grade G3. By conducting this project, we are able to know what the relationships between these variables are and how they may affect each other. The outcome of this project can be used as a reference for parents to know the reasons that may affect the children's grade other than the children's intellectual ability. Several statistical tests are conducted to estimate the relationship between each of the variables. For methodology, the dataset used in this project is obtained from the website kaggle.com. The title of the dataset chosen is Student Grade Prediction. This dataset approaches students' achievement in secondary education of 2 Portuguese schools. The population of the dataset is 395 students. 4 sets of sample data with sample size of 30 will be randomly selected from the population for the statistical test in my project. The original dataset is made out of 33 variables. However, only 5 out of the 33 variables are used in this project, which is the student's home internet access, their address type, and the student's grade for 3 periods, G1, G2, and G3. 4 types of statistical tests are conducted in this project, which are first, hypothesis testing for 2 samples, second, correlation analysis, third, regression analysis, and lastly, chi-square test of independence. All the calculation and analysis of the statistical tests are done by using RStudio. Results and discussions. For hypothesis testing for 2 samples, the null hypothesis is mu1 equals to mu2, while the alternative hypothesis H1 is mu1 not equals to mu2, where mu1 represents the population mean of the first period grade G1, and mu2 represents the population mean of the second period grade G2. The level of significance, alpha, is 0.05, but since this is a two-tailed test, therefore it is divided by 2 and becomes 0.025. The sample size is 30, and the test statistic value calculated, T0, are 12.71869. The critical T value is negative 2.002465 and negative 2.002465. And lastly, the degree of freedom, V, is 58. For conclusion and justification, since T0 equals to 12.71869, which is greater than the critical T value, which is 2.002465, therefore, we reject the null hypothesis. There is sufficient evidence to conclude that the mean of the first period grade, G1, is different from the mean of the second period grade, G2. I think this is because as the content of the exam will be harder as the semester proceeds, therefore, students might not do as well as their first period, which result in the difference of the mean for the 2 periods grade. Next will be the correlation test. This test is to measure the statistical relationship between the second period grade, G2, and the predicted final grade, G3. The sample size is 30. X-axis represents the second period grade while Y represents the final grade, G3, in this scatter plot. The correlation coefficient, R, equals to 0.974495. The scatter plot indicates a strong positive linear relationship between the second period grade and the third period grade. and also the correlation coefficient calculated are close to 1. For the significant test for correlation, for null hypothesis, the null hypothesis is there is no linear correlation between the second period grade G2 and the final grade G3, while the alternative hypothesis is there exists a linear correlation between the second period grade G2 and the final grade G3. For significance level, alpha equals to 0.05, while the degree of freedom, V, equals to 28. The test statistic value, T, equals to 22.979, while the critical T value is 2.04841 and negative 2.04841, while the P value equals 2.2e minus 16, which is negative 10.019779998. The 95% confidence interval for the correlation coefficient is 0.9465374 and 0.9879237. For conclusion and justification, since P value equals to negative 10.019779998, which is less than 0.05, and T value equals to 22.979, which is greater than the critical T value, which is 2.04841. Excuse me. Therefore, we reject the null hypothesis. There is sufficient evidence to support that there is a linear relationship between the second period grade and final grade at the 0.05 significance level. This is mainly because the final grade is predicted based on the first and second period grade. For regression analysis, the median equals to negative 0.016, while the sample size is 30. The null hypothesis H0 is the coefficients are equal to 0, which is no relationship between G2, the x-axis, and G3, the y-axis. While the alternative hypothesis H1 is the coefficients are not equal to 0, which is there is some relationship between G2, x-axis, and G3, y-axis. The RSE, residual standard error, is 0.8076, meaning that the observed final grade G3 values deviate from the true regression line by approximately 0.8076 unit in average. The R-square value is 0.9492. This shows that the second period grade G2 is a good predictor as it is able to explain 94% of the variation in final grade G3. The F statistics equals to 528, producing a p-value of 2.2e minus 16. In this regression test, both the p-value for the intercept and the predictor variable are highly significant. So we can reject the null hypothesis and accept the alternative hypothesis, which means that there is a significant association between the predictor and the outcome variable. For conclusion and justification for regression, the model adequacy check shows that the regression model fits to our data, and the factors such as second period grade G2 are very significant and relevant. The analysis also implies that the second period grade G2 is a good predictor or factor that gives significantly high impact in predicting the final grade G3. The findings is in parallel with the finding in the dataset. Since the dataset have complete information on the student's detail, it will be easy for the researcher to analyze the final grade of the students based on all this information collected in the data. The last test will be the chi-square test of independence. The null hypothesis is the student's home internet access is independent of address type, while the alternative hypothesis is the student's home address is not independent of their address type. the value of test statistic is 1.5, the p-value is 0.2207, the degree of freedom is 1, the significant level alpha equals 0.05, the critical chi-square value is 3.841459. As conclusion, since p-value equals to 0.2207, which is greater than 0.05, or the chi-square value equals to 1.5, which is less than 3.841459, which is the critical chi-square value, therefore fail to reject the null hypothesis. This indicates that the student's home internet access is independent of their address type. This may be because the basic coverage of internet service of Portugal is better in Malaysia than in the rural area. As conclusion, for hypothesis testing on two samples, the mean of first period grade G1 is different from the mean of the second period grade G2. For correlation analysis, it's shown that there is a linear relationship between the second period grade G2 and final grade G3. For regression analysis, the model adequacy check shows that the regression model fits to our data and the factor second period grade G2 are very significant and relevant. The analysis also implies that the second period grade G2 is a good predictor or factor that gives significantly high impact in predicting the final grade G3. The chi-square test of independence shows that the address type of the student is independent of their internet access at home at the 0.05 level of significance. And lastly, the purpose of this project is accomplished as the relationship between the variables investigated has been successfully identified. That is all from me for this project. Thank you.